Okay. Number 18. Okay, 18 says let f be a function that is continuous. Stop there. When you take the test, let us see your eyes on this and everybody look up. Okay, you have to go slow. Like you have the entire period to finish the test. I believe last year, kind of the average was finished in about 45 to 50 minutes, so it's not particularly long. But you have the entire period. Don't go fast. I guarantee you go fast, you'll miss clues and you'll pick the wrong answer. Because these are all old AP problems, as will be the test itself, and they set traps for you all the time. They count on you going too fast, missing a clue, and then one of the answers they give, which is the wrong answer, traps you into thinking it's the right answer. It's common in this class, if people go too fast, to feel like they've done pretty well on the test until the test is graded. And then they don't realize how many traps they actually stepped into. So go slow. It says F is continuous. You have a box on your reference sheet to remind you what that means for F to be continuous. I don't think I put that box here. If you look at the reference sheet, it says that F is continuous as long as F has no jumps, removable discontinuities, or vertical asymptotes. Okay? So if F is continuous, right away, you can stop reading and go look at the answers and say, oh, I can eliminate perhaps an answer. So hands up, can we eliminate any answer based on that clue? Can any answer be eliminated? Scoluccia?
D.
So D has a jump. So D is definitely not the right answer because D is not continuous. How many knew? 2 points. Okay. Questions? Yeah, please, Lynn.
Does C have a vertical asymptote?
Which one?
C.
C kind of looks like it has maybe a, I think you're referring to this little dip here.
Yeah.
I know exactly why you're thinking, because that does look somewhat like a vertical asymptote. If they don't give some other indication, then it doesn't.
Okay.
It's just getting steep here, but they're not putting like the dotted line like this.
So they would put a dotted line.
They would either put a dotted line or they'd have some sort of statement indicating that there is a vertical asymptote. They won't expect you to just kind of wonder.
Okay.
Good question.
If
2
it
more.
was a vertical asymptote, then it wouldn't be continuous?
Correct.
Okay.
So if this had a vertical asymptote and then the function like continued over here, then item C would also not be continuous.
Okay.
What they're saying instead, 2 more for Scarlett, is they're saying we're only looking at this interval from x equal -2 to x equal 3, and this graph they've given you starts precisely at x equal -2 and stops precisely at x equal 3. So it's not an asymptote in that it just keeps going, it stops right there. Okay, keep reading. It says f prime of 0 does not exist. Okay, we need to translate that. I'm going to grab my keyboard so we can type what that means. F prime of 0 does not exist. So let's type out what that really means. We are looking at the graph of f. You can see that because they told us right here which of the following could be the graph of f. That's our question. So we're looking at possible graphs of f. And they then say that f prime of 0 does not exist. So hold on a second. So f prime of 0 does not exist indicates, so somebody raise your hand and tell me what, if you don't know it's okay, but I'm curious if anybody can remember what that would mean. What would it mean to say that f prime of 0 does not exist? Let's go, Maren, please.
Like if in the equation on the bottom, it would be if it tries to divide by 0.
Oh, perfect. So what Marin's saying is if we had an equation for f prime and we plugged in 0, that 0 might cause the denominator of our equation to be 0 as well, which would cause the value of the equation to not exist. Perfect. Two more. What does f prime of 0 not existing mean in terms of f? Because we're looking at f here, and there's no equation. Marin is 100% right. But here we don't have an equation. We just have pictures of f, just various pictures of f. And so what does f prime of 0 not existing mean in terms of these different versions of f? Anyone remember what it means? Let's go here. Sam.
Does it mean you can't find the slope at that point?
Nicely done. 2 more for Sam. Nicely done. So f prime of 0 not existing means you cannot find the slope of f at x equals 0. Let's type that. Something like that. So that's what they are telling you, is that you cannot calculate the slope of f at x equals 0. We learned with Desmos that to find the slope at a point, the way we do that is as follows. We take the point of interest, like right here, x equals 0. We then draw a secant slope to another point on f to the left, and we draw a secant slope to another point on f to the right. You then make the secant slopes shorter and shorter by moving the point, and as you do that, if you can find the slope, the two secant slopes will eventually become the same. So I just want you all to vote on this one. Ready to vote? So if we do that process here, if we make the blue secant shorter and shorter, and we make the green secant shorter and shorter, will the two secant slopes become the same slope, or does it appear that they really won't ever become the same? Hands up. Just vote for one of those two. As we're trying to get closer and closer to this point right here where x is equal to 0. Are the two secant slopes going to become the same, Aspen, or does it look like they're going to stay different? They will stay different, because right here we have a feature which I call a corner. The xy pairs come down sharply. This is not the best printout, so it's a little hard to see. But those xy pairs, they come down like so, and then there's a sharp point where they change, like that, which means if you zoom in on this corner, it will always look like a corner. It doesn't matter how close you get. So there's no way to find the secant slope at that point because the two secant slopes are always different, so we can't find the tangent slope there. There's a box on your reference sheet to remind you of this. It looks like this. It says that a function is differentiable if the function is first continuous. You can't find a slope at a discontinuity for this same reason, that you can't get the two secant slopes to have the same value. A function is not differentiable if there's a corner or a vertical tangent. So for a function to be differentiable, the function must be continuous, and you can't have any corners or vertical tangents. Don't worry about this equation for now. We'll do that in Unit 2. So don't worry about that. You just need to learn the words. So right here we have a corner, which means we cannot find the slope of this version of f at an x-coordinate of 0. But that's what the clue says we are looking for. We're looking for some version of f where f prime of 0 doesn't exist. This meets that requirement. F prime of 0 does not exist at that point. Please, Charity.
Does derivative differentiable, how do you say that?
That's perfect, just keep
Okay.
going.
Anyway, does that just mean that like you can, that whatever it is will always exist, or like that you can find the slope at it?
Yes, perfect. So if f is differentiable at a given point, that means we can find the slope at that point. For example, looking here, and you can either think of it as like secant left, secant, secant left, secant right, and then you shorten them. As we do that here, those two secant slopes will become a single slope. So this function b is differentiable at x equal 2. This function a is not differentiable at x equals 0 because we can't find the slope there by using the two secant slopes.
So if we're finding something that's differentiable, did I say? Anyway, we're looking for something at like a certain point, the slope at a certain point.
If you go either way, they could be saying, hey, this function is always differentiable, or like in this case, they're just saying, hey, this function is differentiable everywhere but 0.
Okay.
And so I look over here at A and say, okay, got it. Like I can find the slope here, I can find the slope here, I can find the slope here, 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 but I can't find the slope at x equals 0. That matches the clue. It's very good. Two more. Anybody else? Please let me.
What's the VT, the vertical tangent?
Vertical tangent means you have a graph that will do something like this. The slope will go straight up at some point. And if the slope goes straight up, we don't know how to quantify that slope. Some would say that slope is infinite. That means it's not differentiable because you can't put a number to the slope. So that's vertical tangent. Two more. This clue here is eliminating, like we've already eliminated D. This clue is eliminating one of the other four, or perhaps two of the other four. So hands up. Who knows which of the remaining four are eliminated with this clue here? Hands up. There we go. Let's go, Sonia. So C, at x equals 0, if you were to zoom in on that spot, the curve would look closer and closer to just like flat, meaning you can find the slope there. By contrast, if you zoom in on this spot, it always looks like a corner no matter how close you get, therefore you can't find the slope there. So Sonia's correct, 2 points if you had your hand raised. C is not the right answer, because we're looking for a version of f where you can't find the slope at x equals 0. Please go.
How is everything else continuous then if you can't find the slope at 0? Like, there's like, what you're saying is there's like two different slopes at 0 on the rest of the graph?
Let me say it back to you. So continuity and differentiability are associated, but they're not the same thing. So continuous means I can draw the graph without ever lifting my pen. I don't encounter any jumps, vertical asymptotes, or removables. That's what continuous means. Differentiable means I can find the slope at a point. So for this version here, I can find the slope at every single point except this one. What I was showing with the two secants is that's how we find slope, like we did with Desmos. You draw a secant to the left, to the right, you draw a secant to the left, you make the secants shorter and shorter in the hope that they will become a single slope. At a corner they won't. They'll always be different because of the sharp corner. The slope here is never going to look like the slope here. They'll always be different. So that means we can't find the slope here, which means this graph is not differentiable at x equals 0. I still don't know if that helped though. I feel like I said a lot and I don't feel like it was on your question really.
No, I feel like it did. I'm good.
Okay. Anybody else? Okay, keep going. F prime of 2 equals 0. Hands up, what does that mean? What does does it mean to say f prime of 2 equals 0? Let's go, Kale.
That at x equals 2, the f prime graph will have a slope of 0.
Close. Let me fix what you said just a little bit. 2 points if you had your hand raised. That really means on the f prime graph that if you went to an x-coordinate of 2, you would find a y-coordinate of 0. So that's what would be happening on f prime. F prime of 2 equals 0. We're looking at f, so something else happens on f. Hands up, everybody. What does this... Kale was right. This is what it would look like on f prime, but what would that look like on f? We lost Griffin and Tyler a little bit. What does that look like on f? Let's go to Sam.
It means that the slope is 0 on at that
So it
point.
means at x equal 2, on f, the slope must be 0. We've already eliminated d. We've eliminated c. So we need to check and see at x equal 2, 2 points if your hand was raised, is the slope 0 at that point? Yep. At x equal 2, is the slope 0 at that point? Good. Okay, that's a useless clue. Stupid test writers. That didn't help at all. Question. Keep reading. F double prime is supposed to be less than 0 for all x except x equals 0. This is where I have to pull out Danica's chart. I have a hard time remembering what that really means without the chart. But once I see Danica's chart, I'm good. So F double prime, put that in a place where you can see it. So F double prime is less than 0. That means if I looked at the slopes of F, I would see them always decreasing. Which means if I look at the curvature of F, I'm going to see a concave down curve. So that tells me which one is the right answer. Hands up, who knows which one is right. Or correct, I should say. Which one, Griffin?
E.
So E is the only of the remaining choices that is always concave down, meaning the slopes of F would be always decreasing. 2 points if you knew that. So E is the correct answer. Please, Len.
Could you just go over that one more time, please?
So the clue is here. F double prime is negative. I'm looking at a graph of F. So that means F double prime is the second derivative of my points. It says all of the F double prime values, if we had a graph of F double prime, we would only see negative points.
Oh.
That says that this other graph must be concave down in shape.
Okay, yeah.
More for London. Oh, please.
I don't see how this is concave down because it goes like this. It like goes concave.
You're good. Let me draw that out for you, Brinley. 2 more. So, let's get some space. Okay, so every teacher kind of has different methods. The method I feel has worked best is this one. That if a set of XY pairs has this type of curvature, or any part of it, that's concave down. If the set of XY pairs has this type of curvature, or any portion of that, that would be concave up. So as I look at this curve on E, this little portion right here, that's matching like this part here, kind of. It doesn't match the green. This part here, that's kind of matching all of this. So they're 2 different sections, but this section is concave down, this section is concave down again. Still bothering me a little bit.
So is it because there's a corner that it's not like concave up?
Yeah, it doesn't switch. You're probably more accustomed to curves that would do this. Concave down, then switching to concave up, and then switching back to concave down. This one just didn't switch. It was concave down, stop, and then concave down again. It has this corner in the middle. That was better. 2 more for Brennan. Please ask me.
So will the F prime graph have a discontinuity in it because of that corner? Is that what it
So the F prime graph will not have a dot at x equal 0. In fact, what you would see is this, Aspen. So Aspen, the slope right here just before the corner, positive or negative? Good. The slope right here, Aspen, just after the corner. So that means if you're graphing F prime, you're going to end up with a dot just before x equals 0 that has a negative value down here. Just after x equals 0, you're going to get a dot that has a positive value up here and no value in between. So it's a jump. But we don't know the slope of f right at x equals 0. So on f prime, there would be no dot at x equals 0. 2 more. Cool. Next one. So stop that.